to the audience. Yes, okay. Yeah, even though we are a little bit critical about big data forecasting, so the review process of this paper has not been too easy, I have to say. Like, we have now it finally under review, but this is a contentious topic, and I mean, it may not that everyone likes the um, the message of this paper. So I would be happy to discuss with you. Actually, I politically disagree with a lot of issues that my colleague Eric Olsen would be in favor of. So we had a lot of discussion writing this paper, and I'm curious whether we will have the same discussions here. I'm in any case open to discuss the outcomes of this paper. We in fact develop a framework for analyzing how you can use big data for getting the wanted outcomes, so the causes that you support, and therefore the subtitle Advocacy versus Accuracy. And I'm also curious to hear whether that's something that you experience actually in your fields of research. I'm originally from the Netherlands. As Maria said, I actually studied economics in Groningen. I also did my PhD in economics, specialized in marketing, and I'm working with marketing modeling, so using quantitative approaches to solve marketing problems. But I'm actually broadly interested, so that is also reflected on my LinkedIn page. I like reading a lot of different things. So this is me. I'm an associate professor here at the marketing department. This is also how I actually got in touch with your school, because we have this Master of Science in Business Analytics, for which I'm the academic responsible. And that meant that we actually collaborated and we exchanged students and faculty for this program. So I've also been to Porto visiting you. Here's also my contact information in case you want to reach out. So then the paper, I mean, of course, I don't have to tell you about big data, but big data has this, I mean, has the promise of actually being, well, it has been compared with like being the fuel of the new economy, right? So the oil of the new economy. I mean, it promised to make better decisions, more accurate decisions, maybe more efficient processes, and maybe also ultimately more objective decisions that were not influenced by human biases. And despite all these promises, I think big data has not really lived up to its potential. At least that's how I see it. And I mean, I like working with big data. I like working with models, but I'm also a little bit critical about the promise of big data and whether it can live up to those expectations that I mentioned earlier. I think there are several reasons why big data has not lived up to its expectations. One is, for instance, that companies have had a lot of focus on, I mean, generating data and making sure their infrastructure is in place for actually collecting and storing the data, but they have focused very little on what is actually the business problem or the business value that they want to create with the data. And well, that's even reflected in the name, like rather than making data-driven decisions, it's better to talk about business-driven data analytics. I think there's also general overconfidence in what big data can do. I'm a big fan of the work by Gerd Gigerenzer. He's a German professor at the Max Planck Institute, and he has this concept which he calls like less is more, which says that if you want to actually predict in radically uncertain environments, it's better to use a simple model that is not overfitted to the data. And he thereby shows that, for instance, heuristics can be pretty effective in decision making. So maybe more data is not always better. A third reason why big data has not lived up to its potential, I think, is because we assume that there's a lot of biases in the data and biases in maybe the algorithms. I mean, feeding a lot of political discussions also these days, and like I think to some extent this is correct, but that may also imply that people are not so happy to use those data that have the biases from the past in it. At the same time, I mean, you can analyze data in many different ways, right? And I mean, if you give people a data set and I mean, you don't really instruct them how to analyze those data, they can get many different outcomes. that may even contradict each other. So there's also different opinions on how to handle the data, how to deal, for instance, with outliers, and how to estimate a model which variables to include, and so on and so forth. And then the last point is, of course, that if you do policy making, right, then in fact, like your policies will also influence the data generating process. So yeah, ultimately you're influencing the data that you collect into the future, and therefore you may have all kinds of things going on that you might not be aware of, for instance, selection effects. So we argue that despite of all those limitations of big data, there is another overlooked element, which is advocacy bias. And advocacy bias is actually a researcher's devotion to changing a status quo. So, for instance, sustainability research, right? People may want to prove that sustainability is a good thing, that companies should focus on more sustainable actions. And therefore, they may actually drive their modeling decisions, sometimes unconsciously, sometimes consciously, into the direction of finding those outcomes. And this is becoming problematic because, well, of course, we have this belief that, when something is done based on scientific method, it's objective, right? But we argue that if you have so much data, it's actually quite easy to find the outcomes that you want to find, and that people can actually selectively look for data that supports their conclusions, maybe include variables that also will help finding those outcomes, especially since predictions are typically correlation based, right? And this is bad practice. And of course, that will harm actually the credibility of what we are doing. And I don't know how it's in Portugal, but I think you see that already in some countries, both here in Norway, but also in the Netherlands. We have seen that governments cut back on funding for research. And that's, of course, in response to the fact that the general public is not so positive about research, for instance, in social sciences. And I think we need to be really careful that we don't get into more problems into the future. So what is underlying this? Well, obviously it's the case that we face several deep crises that we need to solve. And for instance, one of them is the climate crisis. There is a meaning crisis, biodiversity crisis, and obviously, I think the premise that scientists should help solving those crises is actually a good thing. It's maybe a little bit unrealistic to ask that from, let's say, management scholars. I'm in marketing, but I talk here about management in general. And some people even believe that management is complicit in some of those crises, right? So if you talk about people that are unhappy with like the unequal income or wealth distribution, they may criticize capitalism. That they may call people that currently do research like privileged, right? And they claim that we are complicit in some of those crises. Therefore, they argue that management theory needs a reset. And that has basically happened in two different waves, and this is the background of our study. First, and that's something that I have seen in marketing, we still get this criticism. First, people typically say management or marketing is not relevant to practitioners. The academic research is too abstract. It doesn't help practitioners making better decisions. And then the second wave is like it's irrelevant to societal problems. Or in fact, it sometimes even is said that it creates societal problems. And therefore, it's often proposed that we as scholars should actually embrace activism. So a new theory should actually be performative and should help solving those crises. And I don't know how it is in your fields, but in marketing, you really see that some of the topics that are currently studied in marketing are, well, sustainability is a big topic. AI is, of course, a big topic currently, but we also do a lot of research on like minority groups, and this is actively promoted by the leading scholars. this is promoted by the leading journals. It's also promoted by a lot of like funding agencies. If you don't do research on AI or sustainability, well, then you have a hard time getting funding. And it is in fact even the case that our more traditional topics that we study in marketing are to a large extent ignored. You need to do research on those topics in order to get published in the leading journals. And I think that's a bad idea. So then you get headlines like this, leveraging the financial crisis to fulfill the promise of progressive management. International business is contributing to the environmental crisis. We need a great reset of management and organization theory, and so on and so forth. And then, like, of course, the response is that we should do more activism. So a call for activist scholarship in organizational theorizing, answering the crisis with intellectual activism, making a difference as business school scholars, management scholars of the world unite. Well, as I said, this might be bad for the opinion of the general public that, I mean, often thinks that science should be objective and independent of your values. I mean, I don't think that's completely possible. I mean, we study things that we are interested in the first place, so it's value driven. But at the same time, I mean, it becomes extremely obvious if you call for those world bettering causes. This is a statistic that I found in the Springer survey on the Sustainable Development Goals and how they impact research. So I was curious about like what do scholars actually think about this development, and well, most scholars of course find it important that their paper is read by peers, that their paper receives citations, but it also seems to be the case that more and more scholars actually think that that paper should have a societal impact beyond academia. This is most valued in India, surprisingly to some extent actually, followed by the US and Europe. It's seen as highly significant in the social sciences especially, and of course in medicine, which I fully understand. Young researchers seem to be more engaged in doing advocacy research, and especially more than their older counterparts. And public funding is often a factor that motivates researchers to focus on their societal impact. And well, I'm not saying that there's a causal relationship here, but this is some statistics that show that actually among a large group of people, I mean, with different backgrounds, people have less faith in higher education. And I mean, this is politics independent. Of course, there are differences. Republicans have less faith in higher education than Democrats. Education, but it's interesting to see that I mean, it actually happens across all groups, men and women, different age groups, and I think this is a really, really bad development. I assume that in Europe we see the same development, but I couldn't find the right statistics. I want to introduce you to this framework, which I think is a useful way of thinking about like what modeling can do and what modeling cannot do. I got this actually from the books of Nassim Taleb and a couple of articles that he wrote. I distinguish actually between whether you care about being right about the outcome, so whether the outcome is binary, true or false, or whether you also want to be correct about the payoff, so the magnitude of the event. And then I also make a distinction about, okay, are those phenomena that are based on normal distributions or on so-called fat-tailed or power law distributions, or maybe sometimes unknown distributions. And obviously, if we talk about the upper left quadrant, please feel free to ask questions actually if you have any or remarks. I mean, I would be happy to address them. That's the quadrant of the known knowns. This is actually something that Taleb calls the ludic fallacy. This is a domain where we know all the outcomes, and we even can assign a probability to each of the different outcomes. So this is where expected utility theory would actually work. right? But it's of course a very artificial environment, and typically the environment of games, right? So if I roll a dice, I know all the properties of the dice, and assuming that it's fair, I can actually predict the outcomes, and I know exactly how likely each of the outcome is. Of course, their modeling works, but it's not very useful because most of the real world domains are different. Then a situation on the bottom right hand side, which is the exact opposite. This is the quadrant of the unknown unknowns, right? As Donald Rumsfeld has said. Here are things we are not aware of, and we also don't understand. So Taleb has called those events black swan events. And well, you can think of like pandemics, right? You can think of financial crisis. Climate modeling, I would argue, also belongs there. There's a lot of stuff that comes into those that factors into those outcomes that we don't really know. There's a lot of interactions between variables. I mean, there's uneven distribution, so long tail distribution with some outcomes that are extremely unlikely but have enormous impact. And those are the so-called black swans. But then you have also a long tail of outcomes that don't have an enormous impact, but they are less likely. More likely, sorry. Then we have the quadrant of the known unknowns. There you have still the assumption of normal distribution. So if we talk about like life expectancy and credit scores, I mean, those are kind of the outcomes that we know have a normal distribution. So we can use the properties of the normal distributions to still predict outcomes. So insurance companies, that they can perfectly well predict like the outcomes in terms of life expectancy and develop policy based on that. On the bottom left quadrant, we have the unknown knowns. So there's a lot more uncertainty because we have actually those fat tail distributions. In the hard sciences, I mean, you would say like, oh, you understand like the average properties. So we know that like earthquakes follow the Richter scale, but it's really hard to predict like an individual event. And we would argue that's the same for instance, like SAT scores and like, for instance, the chances that people get jobs, like you can, or the salary that they will get. And you can get an average score. I mean, you can find out that a philosophy major may earn less than someone who graduates in economics, but it's really hard to predict the individual level outcomes. So everything that has a known in it might to some extent be modeled, right? But then the unknown unknowns, I mean, the bottom right quadrant is really hard to model. And these are common, right? So here I have an overview of paper by Andirani and McKelvey. I think it was org science, if I'm not mistaken, but I mean, showing which mechanisms actually lead to power laws in organizations. So for instance, one of them is preferential attachment, which is a mechanism where you get like the rich get richer. And I mean, we of course notice that in our current economy, right, which is like a positive feedback economy, because if you're already successful, you're more likely to become even more successful or more wealthy. And of course, that's something that happens in a lot of settings, especially those where there is contagion, right? So if you think about book sales or movie sales or like just popularity, Taylor Swift with her music, right? Then you see a lot of those long tail distributions. But it's very common to have actually these kind of power law distributions also in organizational research, even though often we assume that they are normally distributed outcomes. And then, of course, I mean, we think often that complexification helps, right? If you have a complex problem, we assume that you need a complex model, right? People systematically overlook subtractive changes. Taleb calls this in his book actually via negativa. He uses famous example where if you want to predict like the future, like how will society look in a couple of decades from now, he says, okay, what you do is actually not adding things like flying cars or whatsoever, but you remove things that are currently there but are fragile. Interesting thoughts he has around this, because he also comes up with the so-called Lindy effect. This is basically saying that, you know, an artifact has the expected future life expectancy that is equal to its current age, right? So if something has been around for 10 years, it's most likely to be around for another 10 years. But the point here is that we typically complexify our models, which obviously make them less likely to also hold into the future. Obviously, if you look at these two graphs, right, and like we use different modeling approaches. So on the left-hand side, we have our training data, and we fit the best possible model, right? And okay, that's the more complex model. Well, that model is going to be the least well predictor for the future observations, right? And this is the London daily temperature in the 2000s. And well, you can see on the right-hand side that we have actually a lot of prediction errors resulting from variance because of the model overfitting if we actually increase the degree of the polynomial. So a simpler model would actually lead to better predictions into the future. And this is my point, that like we should actually think about, okay, what is exactly the task of our modeling exercise? Do we really want to explain something? Okay, then we want to reduce bias, and we want to have the complex model that actually rules out other variables, the influence of other variables. If we want to do prediction, maybe we want to have actually simpler model that is more likely to hold into the future, but also more likely to hold across different settings. Some people have argued that this is actually part of the reason that we have replication crisis in, for instance, social psychology, because we have emphasis on explanation rather than prediction. And another point, and this may be obvious to some of you, but of course, if you do prediction, then you do not need to have like causal mechanisms into your model, right? You can have correlations that work equally well. This is, for instance, why like stereotyping works. It's kind of an underfitted model, and it might not be right, but that's exactly the point. Like it works because it's not right, but it correlates with the outcome. So what is then the reason for advocacy? And I would argue that in this quadrant of Taleb with the unknown unknowns, we get a lot of like discussion around, okay, which variables come into play here. So there it's easier to actually come up with a model that satisfies your supported outcome. What is behind this this advocacy for status quo change? Well, typically this is cognitive dissonance, right? Cognitive dissonance is an unpleasant feeling stemming from like incongruence between your beliefs and reality. And of course, you can handle that in two different ways. I mean, this is what we do. Our brains are predictive after all. So you can change your beliefs, right? So that they are in line again with reality. But of course, you can also try to change reality to preserve your beliefs. And then you're basically mistaking the map for the territory. And we argue that, I mean, a lot of contentious topics will most likely lead to conflicts between advocacy and accuracy. So that's why we see a lot of discussion around gender, race, sexual orientation. These are actually rare events typically. And rare events, I mean, it's really hard to actually sample in the real world, right? So you get a lot of discussion around this. It's a little bit related to Philip Tetlock's work. Philip Tetlock calls about two types of forecasters. Like you have hedgehogs that have kind of a belief system, and that belief system they don't want to compromise on. So if you are like a progressive, right, then you try to fit everything that you see out in the world in those in that framework, and everything that doesn't fit you either ignore or you suppress the reality that shows that, or the other way around for like a conservative. And a fox is actually the best super predictor, because those are people that can actually handle ambiguity. they are more eager to deal with disconfirming data, and they are more open-minded. They show humility, and therefore they are more often the better predictors. The bad thing is that those people will not be invited to give a talk, because people like people with strong opinions, right? So on TV or in newspaper, you typically see hedgehogs presenting their work because they have the strong beliefs that people really like, and people love certainty, of course. But the fox, like most scientists should be, right? They say, okay, on the one hand, it's complicated, on the one hand it's this, on the other hand this might play a role, and therefore they're able to like get to more realistic forecasts. So then we introduce our framework, and I just want to introduce that with the use of like a couple of examples. And like here, I talk about diversity, equity, and inclusion modeling, and this is in the unwanted quadrant. So there you have actually an undesired, and undesired is actually from the advocate outcome, and you also have undesired data and algorithms. And I will discuss some of the other quadrants as well. And I will use here the example of Harvard. Harvard got actually sued over discrimination against Asians. So Harvard was there was the message should include more Asians during their admissions. However, and of course people would argue, okay, but you're against admitting Asians because like they're underrepresented in your data. However, such arguments actually ignore that there have been in the past already for decades, there have been affirmative actions, right, to get more of those minority groups into college. So actually they should be represented in the data set. And of course, they also ignore a lot of other explanatory variables like, differences in people's abilities and achievement gaps. So when Harvard investigated this issue, they actually found out that the SAT scores for Asian and white applicants were significantly higher than those for Black applicants. And obviously, then you get into a situation where you actually would not want to include SAT scores, but rather just include race. But this is under pressure since we have more data. So you get actually a lot more data into those models. The models, the machine learning algorithms are also able to pick up on a lot of variables that might be implicitly in the data, and therefore are included in the model, just like, the machine learning algorithms will pick up on like diseases that like human evaluators will not see, right? And therefore it's less likely that such kind of advocacy or biases will exist into the future. So that is this quadrant where you have an unknown, so an unwanted outcome and unwanted algorithms from the perspective of the advocate. If we talk about the wanted quadrant, then we can, for instance, talk about like climate change. And I believe in climate change, don't take me wrong, but I also have serious doubts about whether actually the complexity of the climate can be captured in the model. And it was somehow confirmed actually in this Oxford-led experiment that shows that if you adjust like the climate model parameters within a considerable reach, and you just change them by a few decimal, like hundreds, you can actually get from a situation where you have no warming to, let's say, over 10 degrees warming. And that illustrates kind of the sensitivity of this model to assumptions about the model parameters. And in addition to that, of course, we have also a lot of issues with data quality around climate. So I would argue here for a little bit of humility about what we can actually model. Even though I think this is a serious issue that needs to be addressed, but like think about data quality issues, right? Like only like temperature data but also carbon dioxide emissions data we only have reliably back for just like a couple of decades, let's say 1970s. And before that, we actually have to infer the data from, let's say, tree rings, or like the data from the ice sheets. There's, of course, sites where we don't have data, they're undersampled. And even if we assume that like the measurement points have been always there are changes in the environment that have also led to a change in climate, right? Like urbanization in a lot of regions has led to higher temperatures in the areas where sensors are located, which is not necessarily because of climate change, but will of course affect like the modeling of the climate change. Another issue that makes this harder to predict is also a lot of other factors with interactions, right? So like in the future, we actually may experience like a slowing human population growth. We also see that a lot of parts in the world actually have increased their wealth. And well, we have seen in the Western world that an increase in wealth and education leads typically to less carbon dioxide emissions. I mean, when they become aware of the problem, right? Maybe in the short run, it will still increase. And hopefully our policies will actually lead to a more efficient use of natural resources. So there are so many factors, including their interactions, that play a role that I think it's really hard to make a statement that we can actually predict this accurately. Obviously, then in such situations, you would want to rely on multiple models, so a kind of ensemble of models that gives us predictions. And if you take the average of those, then you would be more likely in the range of where this might go. But then, of course, you also have the problem that most of those research groups are not truly independent, right? In order to get published, you would want to show, well, you would have to show probably that this is kind of an issue. And I mean, only ensembles may work if the observations are independent. To get to more business-related topic, this is the studies that I found about sustainability and the efforts that companies do to help the environment. This was about ESG courses and their impact on profitability. So profits, but also shareholder value of the company. Well, you can see that the majority of the studies reports positive effects. There are some studies with mixed effects, and very few of them have actually negative effects. And that might all be true. I mean, I don't know, but there's, of course, I mean, probably file drawer problems with studies that have negative or no effect, I mean, not getting published. And obviously, you may actually wonder whether this is actually the right focus. I mean, the effect sizes are extremely small. So most of the studies find just 1 to 4% of the explained variance in company performance to be attributed to environmental performance. There's also a possibility for reverse causality, right? If the company makes a lot of money, it's more likely that you actually focus on the environment. And it makes me go to the next point, because also if you actually well, from evolutionary theory, you know that signaling actually works, right? If you invest in sustainability, you actually show to your investors that the company is financially doing well and that the company is well managed, and that may be also causing the higher stock price, even though there is not a causal effect of the environmental performance on profitability. So, I mean, I'm not saying that this cannot be the case. I'm just saying that we need to be really careful about whether those are actually really the mechanisms, and that, I mean, all companies that focus on environmental performance will necessarily lead to, will get more profitable. So, to conclude, actually, you have more discussion about research in the unknown and known quadrant. where there's a lot of uncertainty, where you have rare events, it's really hard to get reliable data on rare events, right? This is both true for, I mean, our brains, right? How they update, like they sample from real life experiences. Well, that is why we typically over predict black swan events, because they're very salient. So they have a strong place in our memories, but they are still much less likely to happen, and they don't appear in our samples typically. That was what happened with COVID, right? I mean, most of us had never experienced a pandemic before, but it became extremely salient, and that is also reflected in the way we dealt with it. If advocacy becomes dominant, and I mean, I definitely see that in my field, its proponents will get the more favorable reviews, it will get citations and also the promotions, and I guess that also a little bit the hard process around publishing this paper is actually indicative of this difficulty. So science might not necessarily only about uncovering truth, but it also becomes a little bit about like reinforcing existing narratives, securing funding because the agencies want you to study research that's I mean is about certain causes, but also shows certain outcomes around those causes. And it might be that we are more and more aligning ourselves with political and corporate interests. And obviously, I agree with all of this, that means science should help solving the societal crisis. But I also think that we should actually foster innovation, which is truly dependent on diversity of perspectives over conformity. So I'm a bit worried about this development, and I actually think that if possible, we should actually counter this trend and I mean be more open-minded. Well, do we have evidence for that this is happening? Well, of course, it's hard to prove that this is because of this advocacy research, but you see that science becomes more about looking where the light is, right? So this is this famous street light effect, where a guy is actually asked, like, why is he looking for his keys where the street light is? And he said, okay, it's just easier to search here. But that may be true for science as well. Like we go for the low hanging fruit where it's easy to score, where we actually establish our reputation among our peers, but we are not truly solving the problems. And well, in this paper by Park, Leahy, and Funk, they actually show that there is a decline in the disruptive science and technology across a whole bunch of fields. So the life sciences, the physical sciences, the social sciences, and also technology. And well, the papers and patents, they are also using narrow portions of the literature. And I think this is the consequence of our, I mean, hyper specialization, of course. But I mean, I also think that most societal problems are not solved by being hyper specialized. It should come from people working together across domains, which is exactly the diversity perspective that I would argue for. And I actually think those developments I mean, all going in the wrong direction. So I hope we can counter some of those. So what do we do about this, right? And of course, I don't have the answers necessarily. I'm also not in the position to actually make those changes, but I can at least come up with some suggestions. I think from my perspective, I mean, at least in marketing, but also more in management research, I think it should be made more okay to work on the traditional topics. So like in marketing, let's focus on like advertising effectiveness, like price elasticity research, but also on digital tools, but not necessarily about like the more contentious and hot topics. We should also focus less on facts. I think one of the main things that science should embody is actually that we should focus on things that I mean that we have thought about for a long time, right? And I mean it's all well and nice that we all focus on the large language models, but I mean, are there not more pressing issues that we can study? So we need to go a little bit away from that's interesting, and instead maybe have some topics that are maybe not that exciting or considered exciting to work on. We need increased transparency about data and modeling choices. In social psychology, they actually have made these changes. You need to pre-register your work in your hypothesis. And more journals are actually asking about this transparency and sharing the data. I work with like secondary data. It's a bit harder to share those data because they typically come from companies. But I think in principle, it's actually a good idea to explain the modeling choices that you have made and the exclusion or inclusion of certain variables. It's not very popular, but I think we should also have more application studies, just showing the same effect, maybe in a different context, or maybe there's a moderator that shows boundary conditions for the effect, like it doesn't hold in this situation, but it does hold in another situation. And maybe, this is just my thought, maybe a little bit more emphasis on prediction, because prediction requires us to focus on simpler models. And they are more likely to hold in the future versus explanation. Explanation is interesting, of course, too, but like we're ultimately interested about future problems. And well, my wish is also for more openness, more humility, maybe a little bit more diversity in our universities, and at least respect for people with opposing views. That's the whole point of science, the dialectic process that we actually try to have competing hypotheses and ultimately over time work out which hypothesis actually fits best with reality. So that's what I wanted to talk about, and these are then the two views of management research that you could subscribe to, like exposing, protesting inequality, exploitation, poverty, hierarchy, plus devising alternatives that are more emancipatory, egalitarian, and they are about the world as it should be, versus management research as a scientific project, the value neutral analysis of the business universe as far as possible, because of course it's not completely possible, using the attained knowledge for purposes of design and applied science. So, I mean, we can of course inform politicians and decision makers in companies about what they should do to obtain a certain outcome without having to tell them what to do, right? And I think that is the view that I stand for, and I hope that more and more people subscribe to this idea. So thank you for the talk. I would be curious to get any questions or like remarks or anything that you would like to comment on.